ஓகே வருதுன்னு நினைக்கிறேன். ஆய் 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 ஆய்.
And I want to print this name. I want to say, hey, this name. And this name might be Raj. So if I say just print name, what will happen? See, it'll still print a Striver.
Yeah.
I want you to print a Raj. This is where something like a parameterized void function comes in. I know I have to take this name. Maybe I'll pass this name. So I'm saying print name, take this name. Print name will say, okay, please give me this. What, oh, by the way, string. What is the data type of this name? It says string. I'm passing the name, but it gives you red. Why? Because this guy is not taking any parameters, but I'm giving it name. I'll say, okay, what are you giving me? You're giving me a string. I'll take the string. I'll take the string. When I've taken the string, now I'll say, hey, can I say name? See what this function took this name and printed. Now this moment when you say Raj, see what happens.
Raj.
Hey Raj. If you say Striver, it will say hey Striver. If you say Aman, it will say hey Aman. Simple. This function, what is the function of this function? Takes a name and prints a name. Very simple. It can take any name. So you can maybe use it again. See string, name 2. And you can maybe take name 2 and you can say print name. See reusability of codes. I'm using the code again and again. And I can say, okay, Aman and then Raj. And then maybe over here, let's give an endl so that every time it says hey, you like see what happens. Hey Aman, hey Raj. Now, had you written this line, you'd have written it again and again and again. But this is where reusability of code comes in. Now this is not under, like you can maybe put it under for loop, that is okay. But if there will be cases where you cannot use for loops, but you have to use shuttle lines of code again at different places. That is where something like a function comes. So I can call this as a void function. And as well as a parameterized function. So you have understood void, you have understood parameterized, you have understood non-parameterized. Okay, now the next question that we will do is take two numbers and print its sum. So what I'll do is I'll take two numbers. The two numbers are on the input. So let's do this. id num1, num2. Let's take the two numbers num1 and num2. Now I'll say cout of num1 plus num2, or maybe you can do it something like id num3 equal to num1 plus num2. I can say let's print num3. Perfect. What will happen? 5 plus 6, 11 will be printed. Imagine this addition operation, you have to do it multiple times. Imagine you're writing a program for calculator, plus. One thing you can do, it will always be like integer, sum. Again, the name of the function can be anything. It always takes two numbers. So there can be two parameters. There can be any number of parameters, multiple data types. You can have something like char C as well. That is okay. Num2. This is num3 equal to num1 plus num2. And you can say return num3. And over here what you can say is, I've taken the inputs and I can say the result will be, I'll say the sum guy to take num1 and to take num2. So the sum guy is called. So what happens? Let's understand the
straight VFR again. Oh, it's live. Sorry, brother. எனக்கு இங்கே லைவ் காட்டுது, இந்த இடத்துல லைவ் காட்ட மாட்டேன். இது சிம்பிள் காட்டிட்டு இருந்தது காட்ட மாட்டேன். என்ன கிளம்புனே தெரியல பசங்க. சரி ஓகே, ஏதாவது பண்ணுங்க.
Line of executions. So what happens? Let's understand the execution. So the main says, okay, num1, num2. Take it as input. 5 and 6. 5 goes to num1. 6 goes to num2. And then I call sum. This is where the program stops. The program stops at the line 21. Program stops at line 21. And now it goes to line 13. At 13, it is taking num1, which is 5. It is taking num2, which is 6. So 5 and 6 are passed over here. And it states 5 plus 6. And then num3 takes 5 plus 6, which is 11. And it says return the value. So it returns
return
11.
the value.
And this function gives you 11. Because this
Ayyo.
function was called, this function gave you 11. Now that 11 goes and gets stored into res. And then the line 21, which was stopped, will be executed. And then this line 22 will be performed. What is the value of res now? It is 11. So it gets printed. So whenever you're calling a function, first the function will be executed. Whatever value the function gives, if it is a return, that will be stored here. Then the remaining lines will be executed.
Oh my
On a function
God.
call, the flow will go to the
Okay,
function.
bro.
The flow will go to the
Like,
function.
bro.
Got it? This is what you call as a return function. This will return something. You could have done it as a void function, void parameterize, and you could have done cout now. That is also okay. In that case, you don't have to do this, and you don't have to do this. Different ways of writing code. A lot of people write code in different ways. You can try it as you wish. My main idea is to teach you what are functions, what different kind of functions you can have. Now remember one thing, if you are writing as this and this can be anything. This can be an integer, can be a double, can be a long, can be a string, can be an array, can be a vector, can be a list, can be anything, And you will see eventually in the DSA playlist, we will be writing functions where we'll be returning vectors, arrays, 2D arrays. There'll be a lot of things returned from here. And we will learn throughout the course. So please make sure you watch all the videos of this playlist because I'm going to go in super depth. Since we're talking about functions, let's take these couple of numbers again. And there are a lot of internal functions. Remember, at the start I said there is something as math.h. So there is an inbuilt function which says give me minimum. And if you write min and you give them num1, num2, and then you print minimum, see what will happen. The 5 is the minimum. Similarly, there is max as well. But there are a lot of inbuilt functions as well. Now, these functions are similarly written. So if you have to write a max function, how will you write? It will be very simple. It will be like num1, num2. And I know if I'm looking for max, if num1 conditional statement greater than num2, I can say that
Sum irukkan.
my max is num1. So, right? Or else I can say is my max is num2. Now there is something you cannot name the function with the same name to make it max, okay? So because inbuilt max function exists, so you have to give the function such a name that the inbuilt there is no such inbuilt functions. There cannot be repetition of function names. Okay, so max. Now, will it work? It should, because data type returns. Let's see. Will it work? It does return. Okay. Now, for an example, let's omit this line. For an example, just for an instance, let's omit this line. This is an integer. This has a return string. Will it work? No, it did throw some random value. Why did this happen? Can you please tell me why did this happen? The reason this happened was, let's understand one thing over here. What did I say? I said number 1 greater than equal to number 2. So 5 was greater than equal to 6. No. So there was no if. Since this if did not execute itself, by the way, since there is one line, you can always write it without braces. Since this if was not executed, because I was stating is 5 greater than equal to 6, and that was false. So the if never got executed. And since the if did not get executed, the return line was not executed. And since the return line was not executed, this function was looking for a return line. It was looking for a return line, and it did not find one. Thereby, it did give you like garbage stuff. So the program did not compile properly. It's very important that if you are writing an int data type stating that it will always have a return, you make sure you write a return. That is very, very important. Every function with a return data type must have a return one, right? Make sure you do that. So we did learn about functions. but in the bracket it is written pass by reference and value. Let's understand what that means. So let's just take a number just in order to understand and do something. And we write a function, do something, and pass the number. Okay, and we go over here and write void. You know this is a function, so write do something and take this number and maybe print it and go ahead, change this number, let's say add 5 to it, again print it, and maybe again add a 5 to it and again print it. So what will be the expected value? I'm sending 10, so 10 will be printed, then plus 5, 15, then 20. So ideally it should be 10, 15, 20. It is. But what did I say about the execution? How does the execution works? So it is like the first line is executed, then it calls it. So it goes here, this is executed, this is executed, this is, then this, and then the line 21, then the 22, then ends at 23. So ideally, if I print it here, what should happen? Ideally, according to you, number was 10, it went here, 10, 15, 20, finished, 21. At 21, it should be again 20 because the last value was 20, so it should be 20, right? Let's do. We run this. 10, 15, 20, 20 till here. But the moment it came to the line 21, the value was 10 again. Why? This is what we call as pass by value. According to you, number was 10, it went here, 10.
Do something, int count நம்ம அது வந்து வாய்ட் ஃபங்க்ஷன் மெயின் ஃபங்க்ஷன் நம்பர் 10 கொடுக்குறோம்னா நம்பர் 10 கொடுத்துட்டு அதை அடுத்து அங்கே போடுறோம், அதை இது பண்ணிடுச்சு. அப்புறம் +5 = 15. ஓகே, நம் = +5 ஆட் பண்ண சொல்கிறோம். ஸோ ஆட் பண்ணோன்னா நம்மோட ஆட் பண்ணால் என்ன ஆகும்? 15 பிரிண்ட் பண்ணுவோம், 15 பிரிண்ட் பண்ணிவிட்டு 10 பிரிண்ட் பண்ணுவோம், 15 பிரிண்ட் பண்ணுவோம், 20 பிரிண்ட் பண்ணுவோம், அப்புறம் திருப்பி 10 பிரிண்ட் பண்ணுவோம். கரெக்டு. அந்த ஃபங்க்ஷன் ரன் ஆகி முடிச்சு, அதுக்கப்புறம் கடைசியில் இந்த ஃபங்க்ஷன்
10, 15, 20.
ஆமாம்ல. வாட் இது என்ன வாய்டு எதுவுமே ரிட்டர்ன் பண்ணாது. ஸோ வேல்யூ வந்து சேமாக தான் இருக்கும். ஸோ
Finished. The last value was 20. 20 till here. But the moment it came to the line 21, the value was 10 again. Why? This is what we call as pass by value. What happens is when you call functions and you pass number, it goes by value. A copy goes. The original number did not go. The original number did not go. This original number must be somewhere in the memory. That original memory did not go. What it created was, it said, you are 10. Let me create a copy. Send that copy. I'm not sending original. This guy took the original. He said, you're 10. Copy. Take the copy and give it to the function. And the function took the copy, did everything with the copy. So he changed, he modified the copy. So since he modified the copy, the original value still stayed the same. This is what we call as pass by value. Okay, this does work with everything. Like let's assign string s equal to Raj, and imagine you pass the string s, and let's omit this, and let's say string s again, and over here assume you say s0 equal to, instead of Raj I say Taj t, and I print the string s, and over here also I print the string s. So ideally over here, if I'm changing s0 to t, Raj will become Taj, right? And then when it comes back, s is again printed. So what should happen? Yes, first it got changed, but since I did not pass the original, I passed the copy. Since I passed the copy, what happened was only the copy got changed and the original still stayed the same. This is what we call as pass by value. Now, there's something as pass by reference. what is this pass by reference? I don't want to pass a copy. I want my function to make changes on the original one. That's when you just attach an and to it. If you attach an and to it, it takes the address. It takes the address. So whatever you're sending over here, it takes the original and sends it. So this string, whenever you say S, it actually is dealing with the original. So let's now compile and see. So if you compile and see, you see it changed here and the same prevailed over here. This is what you call as pass by reference. Understood? If you're passing like this and sign will say that, okay, get it from the address, get it from the address, get the original value. Okay? Now this pass by reference can be written in a lot of other ways, but I personally feel the other ways are very, very confusing. The easiest way is just attach and sign, and that will make sure that it is passed by.
இதை பாரு ப்ரோ, இதை மறந்துட்டேன். அதெல்லாம் தூக்கம் வருது ப்ரோ எனக்கு. ஃபோக்கஸ் பீரியட் ரைட்டாக தூங்கணும் போல இருக்கு. ரைட்டாக 17:06. ஓகே, பட் ஆனால் நான் இன்னைக்கு எவ்வளோ படிக்கலையே. காலைல 1 மணி நேரம் தான் படித்தேன். இப்போ வந்து நான் இன்னும் 4 hours படிக்கணும். 5 ஆகுது. இன்னும் 6 வரைக்கும் படித்தேன்னா கூட இன்னும் 3 hours படிக்கணும்னு வச்சுக்கோங்க. இன்னும் 8 to ஒரு 10 படிச்சுக்கலாம். 10 படிச்சுட்டு போயிடலாம். 4 to 5 hours, 5 hours கிட்டத்தட்ட படிக்கணும். போகவே இல்லைன்னு வச்சுக்கோங்க. I can't sleep right now, so போயிட்டு ஒரு up next 27 minutes under focus session. இப்போதே காணாமல் தண்ணி குடிச்சிட்டு அவனே காலேஜ் வந்துட்டான். அவன் இப்போதான் 2 மணிக்கு தான் வந்தானே. என்னன்னா வந்துட்டேன் காய்ஸ். இன்னும் வந்து இருக்குது. இன்னும் ஒரு 1 minute போனாங்க. போட்டேன். And then we have to hit that. Let's see how long that is. 2 hours. ப்ரோ என்ன ப்ரோ அதுக்கு முடிஞ்சிச்சு. ஓகே ஸ்ட்ரீம் ஆகிட்டு இருக்கா அதுவே தெரில, அதை போய் செக் பண்ணணும். காண்டு ப்ரோ அதெல்லாம் இதுதான் ஸ்ட்ரீமே பண்ணுறது. ஸ்ட்ரீம் பண்ணுறது இதுதான் ஸ்டாப் ஸ்ட்ரீம் ஆகிட்டு தான் இருக்குது. ஸோ ஓகே
reference, the original value is pass.
Okay. So let's do this. Void do something. String yes.
So if you want to pass.
Okay. Void do something. Yeah. String ampersand is okay. S of 0 counter okay int minus string s Raj do something yes okay string கொடுக்குறோம். ஸ்ட்ரிங் கொடுக்கும்போது ஆம்பர்சைனஸ்னு போடுறான். எதுக்குன்னு கேட்டால் தெரில. பாஸ் பை ரெஃபரன்ஸுன்றாங்க. ஸோ எஸ் ஆஃப் 0 வந்து டீயான்னு கேட்குறாங்க. எஸ் ஆஃப் 0 வந்து டீன்னு மாற்றுறாங்க. மாற்றினோடனே டாஜ் அப்படின்னு வருது. ஓ மை காட். அப்புறம் சேஞ்ச் பண்ணக்கப்புறமும் இங்கே வந்து டாஜா வாய்ப்பு இல்லை.
Integer over here. This is what you call on the original one. That's when you just
ஓகே. இப்போ வந்து நார்மல் ஸ்ட்ரிங் இது கொடுத்தோன்னா அது ஜஸ்ட் பிரிண்ட் பண்ணிவிட்டு ரிட்டன் வேல்யூ எதுவுமே கிடையாது. பாஸ் பை ரெஃபரன்ஸ் அதாவது there is no return. ஆமாம் வாய்டு தான் ரிட்டர்ன் பண்ணாது. எப்படி
attach an and to it. If you attach an and to it, it takes the address. So what we are sending over here, it takes the original and sends it. So this string, whenever you say s, it actually is dealing with the original. So let's now compile and see. So if you compile and see, you see it changed here and the same prevailed over here. This is what you call as path.
அந்த அட்ரஸ் கொடுக்குறோம்ல, அட்ரஸ் கொடுத்தா ஸோ லைக் அது ஒரு காப்பியே எடுத்துக்கிட்டு அது வந்து ஒரு சேவ் பண்ணி வச்சுக்கோங்க. ஸோ சேஞ்ச் ஆகணுன்னா இது சேஞ்ச் ஆகிடுது, டோட்டலாகவே சேஞ்ச் ஆகிடுது.
By reference. Understood? If you're passing like this and sign will say that, okay, get it from the address, get the original value. Okay, this pass by reference can be written in a lot of other ways, but I personally feel the other ways are very, very confusing. The easiest way is just attach and sign, and that will make sure that it is passed by reference. The original value is passed. So if you want to pass the integer, similarly you can do integer num equal to 10, and you can pass a num here, and let's print the num here, and again take int, and just pass the num here, and you can go ahead and say let's do the same thing. Cout of num and l, and over here you can say num plus equal to 5. Again you can say cout of num and l. Again you can say num plus equal to 5, and again you can say cout num and l. So let's do. So if I run this, what should happen? See, the value got updated in the
okay. Wait. Num equal to 10 எடுத்துகிட்டு போய் அங்கே போடுறாங்க. போட்டோடனே அது வந்து ரெஃபரன்ஸாக போடுறதுனால என்ன ஆகுது, அந்த நம்பரே எடுத்துகிட்டு போய் மாறிடுது. ஸோ இதுவே நீ ரெஃபரன்ஸ் போடாமல் போட்டோன்னா நம் மாறும். ஆனால் மெயின் ஃபங்க்ஷனில் கடைசியாக பிரிண்ட் பண்ணும்போது அதே நம்பர் தான் பிரிண்ட் ஆகும். ஓகே, ஏன்னா அது வாய்ட்லேருந்து உனக்கு ரிட்டன் வேல்யூ வராது. அதுவே ரெஃபரன்ஸ் போட்டோன்னா உனக்கு மாறிடும். மாறினதுக்கப்புறம் இங்கே வந்து இப்பயே அங்கேருந்து ரிட்டன் வேல்யூ வராது, ஆனால் மாறிடும். புரியுதா? அட்ரஸ் போடும்போது. ஓ ஃபக். ஓகே சாரி. ஓகே எல்லாம் புரிஞ்சிச்சு. ஸோ நம் ப்ளஸ் 5 ஈக்குவல் டு 5. ஸோ 15 ஆகுது, 20 ஆகுது, 15 ஆகுது பிரிண்ட் பண்ணுறான், 20 ஆகுது பிரிண்ட் பண்ணுறான். அப்புறம் இங்கே பிரிண்ட் பண்ணுவோம் 20. ஓகே.
function 3.
Just enter your domain.
Sorry.
Thing that you have to keep in the mind. Imagine you are declaring the array. So do you remember declaring the array? Till now you were declaring the array like 5, and imagine there are like 5 values, 10, 7, 12, 13. Till now, all these values you were kind of taking like cn array of 0, cn
Yes.
array of 1, cn array of 2, see an array of
So do you have
3,
a function or
see
you have
an
to create
array
a
of
for loop
4.
function?
This is how you took, and eventually you were printing it array of 0, array of 1,
ரெண்டுத்துக்கும் ஒரு
and
for loop
going
create
on
பண்ண
array
தெரியும்.
of
அப்படி பண்ணுவியா இல்ல இதுல மாதிரி ஃபங்க்ஷனே இருக்காது அது யூஸ்
and
பண்றது.
so on. You just printed it like this, right? So if you run this, you saw all the values were getting printed like input and in order to get a clarity. Over here also you can put an and L. So if you just put an
Alright,
and L and run, so
alright.
the first 3 values are printed. But is this a good way? Because there might be 500 numbers. What did you learn? Looping, array. It's combined. Yes. How many? What are you taking? 0, 1, 2, 3, 4. Can I write something else?
For I equals
0.
0, I equals
I know I have to go
5.
till 4. Okay? I have to do this. I have to know this. Can I say Cn?
Okay.
Array of n.
0, right? Yeah.
Can I do this? Can I do this? Cn of array of n.
Yes, you
What do I
can.
have? What's the first value
You
of
can
5?
do this,
0.
brother.
So 0. Array of 0 will get in. So 5 will get in. Then what's the value of 5? 1. So 10 will get in. Array of 1.
See
Right?
out.
And-
Shit. I will try this and suck it up in minutes. Series. Stuff it up in minutes. Okay, and there are 7, I guess. So far, for I in white, what are you typing? இது பைத்தானா என்ன ப்ரோ பைத்தானா ப்ரோ பைத்தானா நக்கல் பண்ணுறீங்களா ப்ரோ அப்படின்ற மாதிரி பண்ணுறடா. இஸ் கிரேட்டர் than or equal to 4. Wait, what? I is less than or equal to 4. Sorry, இந்த இதில் I ++, C++, I++. ஓகே, நான் வந்து இங்கே ஐன்ற ஒரு விஷயத்தே நான் இங்கே இது பண்ணல. உடனே வந்துடுவானுங்க இங்கே இருக்கிறவனுங்க. போதுமா ப்ரோ? துடிச்சிட்டு வரீங்களே ப்ரோ. ஏன் ப்ரோ இப்படி இருக்கீங்க? சின்னுக்கு வந்து இந்த சைடா தெரியலையே. இன்சைட்னே தெரியலையாடா சின்னுக்கு இன்சைட் தான் நான் கரெக்டாக தானே போட்டேன். ARR of 5 0 1 2 3 4 அதாவது இன்புட் வாங்கிக்கோ. அதுக்கப்புறம் சி அவுட் வந்துட்டு ARR of I தானே. நைதான் அதுக்கு முன்னாடி ஆன்சர் or no, it prints every freaking time, right? So no, here நீ போடவே கூடாது சொல்ல போனால். எண்டல் போட்டு முடிச்சுட்டு ஃபார்வர்டு போட்டு வெளியே வந்ததுக்கப்புறம் சி அவுட். இதுக்கு முன்னாடியே பண்ணணும்னா டேய் இப்போ என்னடா பண்ணுறது? எனக்கு வந்து ஒரு வாட்டி தான் பிரிண்ட் ஆகும். அதுக்கப்புறம் இது கீழே அது பிரிண்ட் ஆகும். என்ன பண்ணுவேன்? நீ இன்னும் வாங்கிட்டு அவுட்டுக்கு தனியாக தான் போவியோ. என்ன
And then what's the value of I? So if you try to print the value of I,
இருடா, நான் ரன் பண்ணி பார்த்துக்கிறேன் ஒரு வாட்டி. என்னென்னை தான் ஓ நான் பிரிண்ட் பண்ணுறேன். சாரி மேன். ஸோ 10 20 30 40 50 60 70. ஓகே 1 2 3 0 1 2 3 4 0 1 2 3 4 5 வாட்டி வரும். 3 5 இருக்கு ப்ரோ. ஸோ யா வந்துடுச்சு, பிரிண்ட் ஆகிடுச்சு. எல்லாத்துக்கும் ஹேண்டல் இருக்குது. எப்படி ஃபஸ்ட்டுக்கு ஹேண்டல் வந்துச்சுன்னு தெரில. அது வந்து சீன்னால ஓகே, சீன்னால கரெக்டு தான், ஹேண்டல் தான் வரணும். வெயிட் ஓகே சாரி என்ட்றது ஹேண்டல் கிடையாது. கண்டுபிடிச்சிட்டேன், முடிச்சுட்டேன், குறிச்சிக்கிட்டேன், எல்லாத்தையும் எடுத்து வச்சுக்கிட்டேன். So இப்போ next topic கூட
If you remember for loops, this is the value of array. See out a question, but this doesn't work for arrays. Arrays are generated. Just write array 0. Same way, like this. Maybe put a space and just see everything got printed. So I combined array, loops, and everything. Now, a question comes up. Pass by reference. I said include and to everything, but this doesn't work for arrays. Arrays are generically passed by reference. So if you write this is how you pass an array. So imagine this is the array I took as an input, and I said do something, and I said can you please take this array and maybe the size of the array, and the size of the array is 5. So you can go ahead and maybe declare it in a better way. This, yeah, that's a better way. And maybe you can loop till n-1, or you can loop till n. That is your choice. You can do what.
What if your YouTube binge sessions could actually make you smarter? Yep, this tool turns any video you watch into a
Whatever you wish to. You can loop till n-1 because last index is n-1, or you can write lesser than. Both the conditions are meaning the exact same thing. So over here, I'll take everything. Now what I'll do is, I will go across to every value of, or maybe to just understand, array of 0, I will go ahead and add plus equal to, maybe 100. And over here, I'll print array of value inside function, okay? And I'll say array of 0, please get printed, okay? And I'll say value inside int main after the function, okay? Value inside int main. Let's see if that got added. Do you see this? It stays 105. I did not pass it with reference, but array always goes with reference. So please keep this in mind. We are passing an array.
okay ஆமால
will always go with reference.
Okay brother.
But apart from that, vector, maps, list, everything you have to pass that and sign to make sure that it is passed by reference. Got this? So whatever you do over here with the arrays, that will be definitely modified throughout. So with this, we learn functions passed by reference and value. Time complexity is the next one, which I'll be covering in the next video, because time complexity in itself is a very, very vast topic, and I want you to understand this in proper depth with a lot of examples. Why? Because this is going to be the most important topics. If you go for interviews, they'll be like, do it in the least time complexity. So we'll be doing that in the next one. And if you want to know more about C++, you can definitely watch out the C++ STL video. So if you have seen the video till here, I think you should definitely hit that like button. And if you've understood everything, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So in this lecture, we'll be learning about time complexity, and this is the continuation of Striver's A to Z DSA course/sheet. So if you remember in the previous video, we have covered all of these green tick mark things, and in this video we'll be covering the time complexity. Learn basics and then analyze the next steps. What does that mean? I'll be teaching you the basics of time complexity, what is time complexity, how to compute time complexity, and all the terms related to it. And then eventually, when you go through all the later steps at every problem that we solve, we will be discussing time complexity of every problem in depth. So eventually, when you complete all the steps or all the problems, you will have a very, very good hold on the time complexity part. Now, in this video, I cannot teach you time complexity of very complex codes because you do not know them, right? So once you learn the complex codes and recursion, backtracking, we will be discussing time complexity in depth over here. But as of now, just let's start with the basics. So the first question, what is time complexity? Now, why is time complexity required first of all? Now, whenever you're going to an interview, you might end up writing a piece of code, right? Now, that code, how does an interviewer judge that code? This is where they will analyze the time complexity of the code. Now, they're not going to take your code, run into a machine and see how much time does the machine take, and on the basis of that, tell you that your code is right or wrong. That is not going to happen. This is where something like time complexity comes in. Whatever code you're going to write in an interview, in every interview, they're going to analyze you what is the time complexity, and what is the space complexity. And then on the basis of that, you will be judged, right? So whenever you write a code that might end up taking, let's say, 2 seconds on a machine, or might end up taking 3 seconds on a machine, might end up taking 5 seconds on a machine. So the time taken, will you call it the time complexity? No. You will never call time complexity as time taken. Now you might ask, but why? If a code is taking certain time, that should be its time complexity. Let's give you a very, very easy example to explain why not. Imagine I take this code, this can be any code. I take this code and I run it on 2 machines. One is the old Windows machine and the other one is the new MacBook machine. Now I'm sure the old Windows hypothetically might end up taking 2 seconds to run that code, while the new MacBook, which is a lot more in terms of the lot more latest in terms of the configuration, might end up taking 1 second. So does it mean that your code is taking 1 second, or does it mean that your code is taking 2 seconds? It might happen I bring up some other machine the next day, it might end up taking lesser than 1 second. So depending on the system, the code ends up taking a different time. So that is why time complexity cannot be said as time taken, because it is dependent on system, it is dependent on configuration, right? So this is why this is the first point. Time taken is never equal to time taken, never ever. So you might ask, if time complexity is not time taken, then what is it? That is where I see the definition. The rate, remember, the rate at which the time taken increases, the rate at which the time taken increases with respect to the input, with respect to the input size rather. So what does it mean? Let's explain this with the help of a graph. So again, let's take the same example where I'm saying I have a old Windows machine and example with time complexity cannot be I take this code, this can be any code. I take this code and I run it on 2 machines. First point, time taken is never equal to time taken, never ever. So you might ask, if time complexity is not time taken, then what is it? That is where I see the definition. The rate, remember, the rate at which the time taken increases, the rate at which the time taken increases with respect to the input, with respect to the input size rather. So what does it mean? Let's explain this with the help of a graph. So again, let's take the same example where I'm saying I have a old Windows machine and I have a new MacBook. Okay. Now imagine you are giving the old Windows a size 10, just as hypothetical, a size 10 input size, and I'm plotting the graph. And this is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds, this is 5 seconds. This is 10 input size, 20, 30, 40. At 10 input size, it might end up taking 2 seconds. At 20, it might end up taking 4. At 30, it might end up taking 6, which will be here. So you see the time increasing at some theta angle, like it's increasing at a certain slope. So this theta angle is what you call as the rate of increase. This is what you call the rate of increase. Okay, now let's see the new MacBook. So if I take the new MacBook, the 10 might end up taking 1 second, the 20 might end up taking 2 seconds, the 40 might end up taking 3 seconds. So it's here, here, here. So this is the rate, and this theta is the rate for the new MacBook. So I can say the rate at which it increases time is what you call as time complexity. Depending on the input, if they're giving you more input, it might end up taking a certain more time. So the rate at which the time increases is what is generically referred as time complexity of any given code. The next question that might come to your brain is, okay, Stripe, if we are saying the time complexity is not computed in terms of seconds or minutes, then how do we write it? This is where something like a big O notation comes in. Now, in all the interviews that you're going to give, or in all the examinations, if you're writing a piece of code, they will ask you to analyze the time comp. That is when you do not, like, you will not say 2 seconds. No, you will say it in terms of big O notation. Every piece of code takes time in terms of big O notation. What is big O notation? I'll just give you a prime example. So it's like a capital O, open parenthesis, and a close parent. This is what big O notation is. And inside it, you write whatever the time is taken. Inside is, you write the time taken or the hypothetical time, which I'll show you how to compute. Let's take a very, very small example to compute the time complexity of a certain code. So imagine I write the for loop. I've already taught you loops in the previous video. I equal to 1, I lesser than 5, I plus plus, and then I write cout and my name Raj. Okay? So can you tell me what is the big O of this? This is nothing but the number of steps that this code will take. First step is very sure, assigning. The second step is comparison. The third step is printing, right? And then you come across, and this is your fourth step. And then again you check, this is your fifth step. And then again you print, this is your sixth step. So this is how every step is computed. So whatever is the total number of steps, that is what you write inside it, and that is what you call as the prime big O notation. But you cannot just keep on counting step 1, step 2, step 3, step 4, step 5, step 6, step 7. That is insane. You just cannot keep on manually counting the steps. This is where 3 rules come in, and I'll write the rules. The 3 rules are very simple. Always compute time complexity in terms.
சம்மல்ல இந்த மாதிரிலாம் கண்டுபிடிச்சி வச்சிருக்கிறானுங்க யாரு அப்போனா நம்ம எவ்வளோ சின்னதாக போடுறோமோ அது ஓகேவா. அப்போ அந்த ஸ்பேஸ் முக்கியமே இல்லை, ஸ்பேஸ் இருந்ததுன்னா நிறைய நேரம் எடுக்கும்னு நான் நினச்சிட்டு இருந்தேன். இப்போ தான் புரியுது என்ன கதை.
Worst case scenario. Time complexity to be computed in terms of worst case scenario. Why worst case? I'll explain it. The next one is avoid constants. Avoid constants. The third is avoid lower values. So if I have to compute the time complexity or the big O of this piece of code, let's look at it on a very higher level. Can I say this for loop is running for 5 times? I can. At every time, what is happening? It's like increment, check, print, increment, check, print. So can I say for every time it's operating twice, for every time it is operating 3 times, increment, check, print, 5 into 3, can I say this? I can. So can I say a total of 15 times? That is how you write it. You write it as big O of 15 is what you write. And this is time complexity. It runs for 15 times. But this is a number. This is a number. You generally do not represent your code in terms of numbers. Okay? So let's change this. Now, can I say this? If I change just a minute. If I probably will change this to lesser than n, lesser than equal to n. So now can you say how many times will this loop run? I know one thing. This is going to run for big O of n times. The code will run for n times, n iteration. And at every iteration, 1, 2, 3 things will happen. At every iteration, 3 things will happen. Pretty obvious? This is what will be the time complexity. Big O of Tn. Big O of Tn will be your time complexity. So whenever you're saying big O, you go to the code and you see how many times it is running. And then you write big O of Tn as your time complexity. Does that make sense? It does, right? Okay, let's now come back to the 3 points that I've written. Always compute time complexity in terms of worst case scenario. Now, there are 3 things. One is the best case, one is the average case, and the other one is the worst case. Now, let's take a snippet of the code and explain you what is best case, what is average case, and what is
Serious dictation was driving me crazy, so I switched to whisper flow. Here's why I'll never go.
worst case. Okay, let's. So this is the snippet of the. Now imagine, the snippet of the code is very. It states if marks is lesser than 25, print grade D. It states if marks is less than 45, print grade C. If marks is lesser than 65, then you go ahead and print grade B. Or else you go ahead and print grade A. So let's talk about the best case scenario.
Elsa.
What is best case? When the program takes the least amount of time. So over here, can I say, if someone gives you an input of marks equal to, let's say 10, what will happen? This will execute it and grade D will be printed. And none of these lines will be executed. None of these lines. So can I say the number of operations will be just one, a check and a print, which is like 2 operations. Can I say? Imagine if I give you marks equal to 70. So at marks 10, it was BGO of 2 operation. Correct? BGO of 2 operation. Now if I give you marks equal to 70, what will happen? Check, false. Check, false. Check, false. It comes here. 3 and then 4. Can I say 4 operations by here? Like 1, 2, 3 and then goes to else. Somewhere around 4 operations. So it takes 4 operations. So whenever you're analyzing the time complexity, will you say that my code runs in BGO? Or will you say that your code runs in BGO 4? Obviously, you will say BGO 4 because that might be the worst case that the computer might encounter when it is given an input. So always, yes, always compute the time complexity in terms of worst case scenario. And if they will ask you the best case, you know the best case. Whatever is the best case, like in this case, is the first if statement getting executed, which is BGO of 2 operations. So you've got an idea about the best case and the worst case. You know what is the average case. There's nothing but the best plus worst divided by 2. It's the median of it. So pretty self-explanatory. Why? If I give you a question, why do we compute it in terms of worst case? The answer is again self-explanatory. If you're building a system, will you build it for 1 person? Or will you build it for 1 million person? If given an option. You will say 1 million because you want to build a system which can scale up. You always think of the worst that can happen. That is why when I talk about time complexity, your code extreme worst case is what is considered while computing time complexity. Now, let's talk about constants. I'm saying avoid constants. Why am I saying that? Let's take a shuttle example. Let's take something like 4n cube, something like 3n square plus 8. Let's say this. So over here, 4n cube plus 3n square plus 8. These are the number of operations that your code is taking. Hypothetically, I do not know what piece of code. I'm just taking an hypothetical BGO expression. Now, imagine if I tell you that the input size n is somewhere around 10 to the power 5, right? I'm saying 10 to the power 5 is the input size. So when I say 10 to the power 5 and you put that in, what will it be? 10 to the power 15, 10 to the power 5 cube, 15 plus 3n square, that's 3 10 to the power 10 plus 8. Tell me a very easy thing. 10 to the power 15 plus 10 to the power 10 into plus 8. Will this 8 have any significance in the operations? This is in itself such a huge number. If you add 8, will it matter to them? It taking like billion, like whatever is 10 to the power 15, I'm not sure what it is. It's like billion, trillion, whatever, like more than that, I guess. With that, a plus 8, does it have a significance? It doesn't. If you're earning 1 million and I give you $1, that will not have any significance. That is why we do not consider constants. We do not consider constants. Now, in terms of code, imagine I say you something like this: int x equal to 2. So this is the modified code. This is the modified code. X equal to 2, and then the for loop. So this is one operation. It's something like n into 3 plus 1. The time complexity updated will be n into 3 plus 1 operation, and this is the one operation. So you never ever take this unit operation. So you will not consider this. You will say no. It will still stay as n into 3. I will avoid constants because whenever the input size is very large, those constants have very less significance. Got it? Now let's take the next thing. Avoid lower values. Let's take the same example. I'm saying 10 to the power 15. 10 to the power 15. If you add 10 to the power 10 to it, will it have any significance? It won't. So adding 10 to the power 10 to 10 to the power 15, 10 to the power 15 will have absolutely no significance. It is similar to saying I will add, let's say, 1 to 1000. Even less than that. It is similar to actually saying 1 to, yeah, I'm adding 1 to this much. Oh, 1 more 0, yeah. Will it have any significance? No. So adding this one to this one, will it have any significance? No. The number of operations will be slightly. Because 10 to the power 15 in itself is such a huge number. But this is why, again, something very important. Avoid the lower values, which does not change its significance by much. So avoid lower values. Got it? So these are the 3 points that you will always keep in mind while computing the BIGO notation, because BIGO notation is what you will be expressing your code in interviews always. All the problems that I'll be solving, I'll be telling you about BIGO notation only. Apart from BIGO notation, there are certain other terms like theta notation, omega notation. They'll find a lot of other terms in textbooks. Are they required in interviews? No. No one is going to ask you these things. No. But just for knowledge, let me tell you. The BIGO notation is always the highest complexity or the worst case complexity. Remember this. Worst case complexity or the highest or generically known as the upper bound complexity. It's known as the upper bound. The omega is the lower bound. As I said, the kind of the best case is the lower bound or the lowest bound or whatever you can. And this is nothing but the average complexity. Just a quick disclaimer. There are a lot of theoretical stuffs revolving around BIGO, theta, omega, a lot of limit derivations. But I'm not teaching you theory stuff. I'm not teaching you for your semester examinations. I am teaching you for interviews. I'm preparing you for the DSA coding rounds, and they will not be asking it. Over there, they'll be asking you programming logic. You'll have to solve problems. They won't be asking you, tell the formula for Biko notation in limit terms. No one is going to ask. Might be asked in semesters. For that, you'll find different teachers on YouTube. If you're learning from me, you're learning for interviews, for coding rounds, for problem solving abilities, not for your semester exam. So please do not comment that you did not teach the mathematical derivation, because that is something which is not required while problem solving, right? So you know how to compute Biko now. Let's do one thing. Let's quickly solve some questions. Okay. So the first snippet of the code for which you have to find the time complexity. Imagine inside your main, you have something like int I equal to 0, I lesser than n, I plus plus, and for int j equal to 0, j lesser than n, j plus plus, and imagine it has a block of code like something, a single line of code, and this is your entire snippet of the code. Okay, this is your some block of code.
N into n times.
You can consider this to be taking very constant time, so this can be avoided.
N square times.
Tell me the time complexity. You know, time complexity will be computed in terms of Biko notation.
N square.
Tell me the time complexity of this
N
particular
square.
code. Pause the video and maybe think about it and then see
N square.
if you are correct or not. So, how do you analyze the time complexity of snippets of the code? It's very simple. Analyze how's the code working.
வெளில ஒரு n into n times நடக்கும்ல, n into n times ஒரு வாட்டி அது.
So if you see, the outer loop is starting from I equal to 0 and going till n. That's definitely running till n, a bit difficult. I is 0, value from 0. Can I say when I till n? J again from 0. Can I say if I is 2 again, it again goes from 0 till n? Can I say it again? Or rather than n minus 1 to be very accurate? Can I say this? So what is happening? Every time it is running for n, 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 n. Every time it is running for n, n, n. So can I say it's running for n times first, then for another n times second time, then for another n into n? Yes. Thereby n square is the number of iterations it is taking. Yes, there are other things as well, like increase, comparison, but we usually do not consider. Which rule? Avoid lower values if you remember, because 3 into something won't matter that much. Yes, you can avoid it. What I can say is, it's running for n square. Yeah, if you want to consider all these constant operations, you can do it. That is your wish. I usually do not do it. So, Biko of n square is what is the time complexity of this particular. Let's take the next example and try to compute the time complexity of this one. So, it's like the first loop is definitely running for n, and second loop is running from 0 to I. So let's analyze slowly and probably we'll get the time complexity.
வேறு 0லேருந்து 0 அங்கே 0 இங்கே 0. ஸோ உள்ளே இருக்க கோட் வந்து ஒரு டைம் தான் ரன் ஆகும். ரன் ஆனதுக்கப்புறம் முடிஞ்சு போயிடும் லூப்பு. ஓகேவா, ஸ்டார்ட் பண்ணணும். ஸ்டார்ட் பண்ணிட்டு ரன் ஆகும். ரன் ஆகிட்டு ஜே ப்ளஸ் ப்ளஸ் போடும். ஜே ப்ளஸ் ப்ளஸ் போட்டுச்சுன்னா அதுவும் போகும், அதுவும் இன்க்ரீஸ் ஆகும் முடிஞ்சதுக்கப்புறம். ஸோ ஒரு வாட்டி தான் ரன் ஆகும். ஓகேவா, n டைம்ஸ் ரன் ஆகாது, அங்கே 1 டைம் தான் ரன் ஆகும். ஸோ இங்கே n டைம்ஸ் ரன் ஆச்சுன்னா அங்கே n டைம்ஸ் ரன் ஆகும், அவ்வளோதான்.
So can I say,
n plus n
if I equal to 0, j is nothing but from 0 for 0 becomes and 2, j will be, it is taking, again, I'm ignoring all these constant operations, I'm taking the overall iterations. Now, the first time it's 1 iteration, next time it's 2, next time it's 3, 4 until n. So can I say the number of iterations? The first time it is 1, the next time it is 2, the next time it is 3, the next time it is 4, so on till n iterations. Can I say? And do you remember the formula for this particular thing? Some of the first n natural numbers, simple maths. N into n plus 1 whole divided by 2, which is nothing but n square by 2 plus, can I say, n by 2. Thereby, this is the exact time complexity. but we can avoid, if you remember the rules, constant to be avoided, like the smaller values to be avoided. So it will be like n square by 2. So this is the time complexity. Again, if you try to remove the constants like 1 by half, you can say the time complexity is near about we go of n square. But if someone does ask you the exact time complexity, this is the exact time complexity. But according to the rules, this is what it boils down to. So these were the basics of time complexity. Okay. Now next, I'll be doing all these patterns in the next lecture, where I'll be writing all the nested for loops. And there you can analyze time complexity in a much better way. But eventually, all the time complexity terms like log n, n squared, n cubed, n square log n, all of these things you will see as I proceed with the playlist. I do not want to rush you in. I just want you to get an overview of what is time.
ரன் பண்ணுறோம் நம்ம அதுக்கப்புறம் அதுக்கு தகுந்த மாதிரி what the fuck this much is it.
complexity, how to think on it.
வந்துட்டேன். ஓகே ப்ரோ, போயிட்டு அப்புறம் வரேன். நாளைக்கு பார்க்கலாம். நாளைக்கு இல்லை, ஒரு 8 o'clock அந்த மாதிரி வருவேன்னு நினைக்கிறேன். பார்க்கலாம்.